Hi everyone, our lesson today is the multiplication principle. This multiplication principle is studied here in way more detail than other probability books. So let's start. We have these two urns here. The first urn has 5 objects, so the number of objects in it is u equal to 5. And the second urn has 3 objects, 3, 1 and 2. So the number of objects in the second urn is v equal to 3. Now we want to find the number of possible outcomes or sequences of withdrawing from the 2 urns according to the following rules. So what are the rules? The first one, we are withdrawing a ball from the first urn, and after that we withdraw a ball from the second urn and we write the name of the withdrawn balls in order. So now we have the 2 urns. We withdraw from the first urn object D and we write it down here, and then we withdraw from the second urn object 2 and we write it down here, and now we have a sequence D2. But before we continue, we have to remember if replacement or no replacement of object is important. We are withdrawing once from the first urn and once from the second urn. If we withdraw from the first urn twice, then replacement or no replacement would be necessary, because we may withdraw EE or DD, or we may withdraw 2-2, and that will change the whole experiment. Now we are withdrawing only once, therefore replacement does not make any difference. So if we repeat this cycle, we are going to generate sequences, and one process means one cycle, one withdrawal cycle, to generate one random sequence such as D2. So if we repeat this cycle once, we have cycle 1, we may get sequence D2, cycle 2 we may get sequence E3, A2, C1, and so on. Now to find out the number of possible outcome or the sample space, we can use the tree diagram. In this tree diagram, for the first withdrawal, we may get A, B, C, D, or E. And in the next withdrawal, the second withdrawal, we may get 1, 2, and 3. So the possible outcomes are A1, A2, A3, so we may here withdraw B and then withdraw object 3, so we write it down as B3 and so on. So now we need to know the number of all outcomes. So we divide this big tree into subtrees, 5 subtrees. Each subtree contains 3 outcomes, so we add them together and we get 3 5 times, which is 5 times 3. So what is 5 times 3? It is U times V, where U is the number of objects in the first urn, or the number of way of occurrences of the first event, and V is the number of objects in the second urn, or the number of way of occurrences for the second event. So we can conclude the following. Suppose that 2 events occur in order. So we have the first event, withdrawing a ball from the first urn, and that can happen in 5 ways. And we have a second event, withdrawing a ball from the second urn, and this can happen in 3 ways. Then the 2 events can occur in order in 5 times 3 ways, which is 15 ways. So we can state that in general, that if we have 2 events occurring in order, the first one can occur in U way and the second one can occur in V way, then the two events can occur in order in U times V way. But this statement is not really everything. There are more to add to it, and we are going to see what to add to it right now. The multiplication principle contains more cases, and one of these cases can be explained using the following example. We have this urn which contains 5 blue balls and 7 red balls, and we are going to define event U withdrawing a blue object where the number of objects is U equal to 5, and event V withdrawing red objects where the number of red objects is 7. So now we are going to separate the red from the blue, and we want to withdraw from U first and V second, or V first and U second. And the reason we do that is because we are not concerned about withdrawing twice red red or twice blue blue, so we want either blue or red and blue. There is another case for the permutation formula which can be explained using the following question. What is the number of occurrences of both events in all possible orders? So now we have the order of UV and VU. So in such case we have to add the outcome. So we have UV and VU. So we have 7 times 5 plus 5 times 7 equal to 70, or 7 times 5 times 2 equal to 70. But what is this 2 here? It is the permutation of the sets U and V. So what is that permutation? We may choose U set U or set V, and if we choose one we cannot repeat that, so we end up with V and or U. So number of possible outcomes are U, V or VU, and this is permutation of two sets without replacement. We are not repeating U after choosing it again in the first event. Or we can use the table events. In this table event we have number of way of withdrawing the first set, which is 2, and number of way of withdrawing the second set, which is 1, and we end up with 2 times 1, which is 2 factorial. So this 2 here is not more than 2 factorial. And for this reason, the 2 here is a permutation of U and V set in order without replacement. And we can write that in this equation here. 7 times 5 times 2 factorial is equal to 70, and that is the number of occurrences of both events in all possible order. Now we state the multiplication principle of two events or sets for all the previous cases. So we have two events. The first one is U and has U ways of occurrences, and the second one is V and can happen in V ways. Now we have the following cases. Case 1, the product U times V represents the occurrences of both events UV in order of U first and V second, while V times U represents the occurrences of both events VU in order of V first and U second. The product UV or VU represents the occurrences of both events in any order. So that's in case the question is demanding from us that no order is required. So this is the no order case. Now the case of all orders, the product 2 factorials times V times U represents the occurrences of both events or all events in all possible order. So this is all the cases of the multiplication principle for 2 events. Now we are going to generalize it for 3 events and more. But before we do that, what are the conditions to apply the multiplication principle? First condition, each event is defined over a set, not defined over a multiset or a list. The second, the sets are independent from each other, which means they have no mutual element between them. As for the order, we have the following cases. If the question asks for ordered events, we apply the multiplication formula in case of ordered events. If the question asks for non-ordered event, we apply the multiplication formula in case of non-ordered event. And if the question asks for all possible ordered event, we apply the formula for all possible ordered events. So the final notice is replacement here is not important, and the reason is we are withdrawing from each urn only once. Finally, let's look at the multiplication principle in case of 3 events. So we have the first urn, the second and the third, and each one contains few objects. So now we are going to withdraw from the first urn, and we write down here E, and we withdraw from the second urn, object 3, and we write it down here, and we withdraw from the third urn and we write the name of the object here. So now we have a sequence, and if we repeat that, we are going to generate more sequences. So if we do that once, this is a 1 withdrawal cycle to generate 1 random sequence such as E3Q. Suppose that we have 3 events which occur in order one after the other. So the first event can occur in 5 ways, and the second event can occur in 3 ways, and the third event can occur in 7 ways. So the number of ways of occurrences of all these events is 5 times 3 times 7 ways. Now we can write that in formal way. Suppose that 3 events occur in order. If the first can occur in U way, and the second occur in V way, and the third in W way, then the 3 events can occur in order in U times V times W way. We have 3 events, U, V, and W, and they can occur in many orders. So we are going to see what these orders are. They are 6 orders. UVW, UWV until WVU. So we have 6 ways of this event happening one after the other, and now we can generalize the multiplication principle of 3 events or sets. So now we have 3 events. The first event is U and has U way of occurrences. The second event is V and has V way of occurrences, and the third one is W and has W way of occurrences. So we have the following cases. The product U times V times W represents the occurrences of these events in the order of U, V, W. And the product U times W times V represents the occurrences of these events in the order of V, W, and U. So we continue until we arrive at the last way of occurrences of these 3 events. So we have 6 way, which is 3 factorial, and now we arrive at the extra case of the multiplication principle, which is the case of no order. Any of these products, U, V, W, or U, W, and V, etc., any of these products represent the occurrences of these 3 events in any order. So if the question demands from us that these three events occur in no order, we can use the multiplication of UVW or UWV to get the number of outcome of these three events. And finally, the product is 3 factorial times U times V times W represents the occurrences of these events in all possible orders. Why we have here 3 factorials? Because we have 6 ways of organizing these events in 6 different orders. Thank you for listening and have a good day.